Now that we know how first-order systems respond and second-order systems respond, it's time to talk about how multi-order systems respond. So ones that have more than two second order, so third or higher. And we're also going to talk about the effects of zeros on a system. So as we remember, if we had a transfer function is equal to our numerator of s, a numerator of s over a denominator of s, we had that the poles were the solutions of our denominator of s equal to 0. So whatever the s terms cause that equation to be true were the poles. We can also refer to what happens if our numerator is set equal to 0. So the solutions of setting our numerators equal to 0 are going to be our zeros. And while we're talking about adding additional poles, we can also talk about adding additional zeros to our system. So previously we've talked about systems that only had one or two poles, so first order or second order systems. Now we're going to talk about systems that have both poles and zeros. So what I'll need you to do is I'll need you to take out the handout. Take out the handout that was shared on Canvas. So it's called The Summary Effects of Additional Zeros and Additional Poles to a Standard Form of an Underdamped Second Order System. Instead of identifying how these go by taking the derivation of any of these situations, we're just going to look at some examples and build a set of rules and fill out these rules in this handout. So if you don't want to download or print the handout, you can just write the rules as you go along. But I'll have some example systems throughout this packet that you can refer to.